This is the seventh in a series of resources on integral calculus. We define the idea of an integral. We investigate the fundamental theorem of calculus and look at some basic rules for integrals. We explain the difference between definite and indefinite integrals, looking at a basic example. We consider using Riemann sums as a method for approximating a definite integral. We investigate the integrals for specific function forms, including polynomials and trigonometric functions. We will also look at substitution methods to simplify certain integrals. Certain integrals involving trigonometric functions follow directly from the concept of an integral. If we take the derivative of function f and get function g, then it makes sense to think that the integral of function g would be function f. We painstakingly discovered each of these derivatives in the series of resources on derivatives. So the integral of sine of x with respect to x is negative cosine of x. The integral of cosine of x with respect to x is sine of x. The integral of secant squared of x with respect to x is tangent of x. The integral of cosecant squared of x with respect to x is negative cotangent of x. The integral of secant of x multiplied by tangent of x with respect to x is secant of x. The integral of cosecant of x multiplied by cotangent of x with respect to x is cosecant of x. We can use these basic trigonometric integrals along with the idea of u substitution to complete some problems, as we shall see. Suppose we want to find the integral with respect to x of the cosine of the quantity 5x minus 4. As we saw in the previous resource, we can consider a substitution. We consider u equal to 5x minus 4. Then the derivative of u will be 5 multiplied by the derivative of x. Solving, we have dx equal to 1/5 the derivative of u. Substituting into the integral, we have the integral of cosine of u multiplied by 1/5 the derivative of u. Factoring out the constant, we are left with 1/5 the integral with respect to u of cosine of u. Taking the integral, we have 1/5 multiplied by the sine of u plus c. Substituting the original expression back in for u, we have the integral equal to 1/5 of the sine of the quantity 5x minus 4 plus c. Certain trigonometric functions cannot be integrated as written. However, we can find the integral if we use an identity to reimagine the function. Recall that all the other trigonometric functions can be considered ratios involving sine and cosine. Tangent is sine over cosine. Cotangent is cosine over sine. Secant is 1 over cosine. And cosecant is 1 over sine. Let's see how we use these identities to find the integral of a trigonometric function. Suppose we want to find the integral with respect to x of the function tangent of x. We recall that tangent is the same as the ratio sine over cosine. To complete this integral, we will use u substitution. We select u to be the function cosine of x. The derivative of u with respect to x would be the negative sine of x dx. With this substitution, we have the integral with respect to x of tangent of x equal to the integral of negative du over u. Integrating, we have the negative natural logarithm of the absolute value of u plus c. A constant -1 multiplied by a natural logarithm of a quantity is the same as the natural logarithm of the quantity raised to the -1 power. This in turn is equal to the natural logarithm of 1 over the quantity. We have the integral of tangent equal to the natural logarithm of 1 over the absolute value of u plus c. Plugging back in our original function, we have the natural logarithm of 1 over the absolute value of cosine of x plus c. Using our identities once more, we have the integral of tangent of x equal to the natural logarithm of the absolute value of the secant of x plus c. Some integrals require both u substitution and identity substitutions. For example, suppose we want to find the integral with respect to x of 1 over the cosine squared of 2x. First, we recognize 1 over cosine squared is equal to the secant squared. We have the integral with respect to x of secant squared of 2x. Since we have a function of a function, we want to use u substitution to simplify the problem. We set u equal to 2x. The derivative of u would then be 2 dx. Solving, we have dx equal to 1/2 of du. Substituting into the integral, we have the integral of secant squared of u multiplied by 1/2 du. Pulling the 1/2 to the front of the integral, we have 1/2 the integral of secant squared of u du. Completing the integral, we have 1/2 the tangent of u plus c. Plugging back in for u, we find that the integral with respect to x of 1 over the cosine squared of 2x equals 1/2 the tangent of 2x plus c.